Good evening, madam.
Good evening to all participants. A very good welcome to our respected speaker of the today's session, Professor Pankaj Kumar Rai sir. Professor Pankaj Kumar Rai is currently professor and former director of the School of Water Resource Engineering and the School of Environmental Studies, Jadavpur University. He has acted as Dean of the Faculty of Interdisciplinary Studies, Law and Management, Jadavpur University from 2019 to 2021. His thrust area of research includes hydraulics, water resource engineering, fluid mechanics, climate change, and its impact on water resource engineering, surface water pollution and its mitigation, groundwater dynamics, water conservation technology, solid waste management, groundwater treatment, etc. He has completed more than 20 national and international research projects funded by World Bank, EU, State DST, PhD, WB, CPCB, etc. And he has conducted more than 100 consultancy research projects. He has more than 25 years of teaching and research experience, and Professor Roy has published more than 316 research articles in national as well as international journals and published more than 50 research articles as book chapters. He is now working with Switch On Foundation and Water for People to train and support rural women by offering skill enhancement of green groundwater monitoring and level measurement to make them empowered and environmental benefits. He is currently supervising 28 research scholars. He is presently the principal investigator of the World Bank project titled Appointment of Agency for Baseline and User Satisfaction Survey of West Bengal Inland Water Transport Logistics and Spatial Development Project, which has a duration of 3 years and cost over 2.35 crore. I welcome Professor Pankaj Kumar Rai sir to continue the session. Sir, please.
So, first of all, I would like to thank the coordinator who has invited me this kind of a workshop, and thanks to all faculty members from Tripura Institute of Technology and all the participants and respected delegate persons and my beloved students, research scholars. So basically the topics which I had the coordinator has given to me, basically the availability of water, global warming and climate change thrust. As you know, since I am working for last couple of years under this umbrella, so definitely this is a very important issue so far the all states are concerned. So keeping in view, so if you because see this is the climate change is a very big is a big name you can say. So climate change issue, particularly if you talk about the climate change issue, mainly we are talk about the temperature, rainfall pattern, and so on. And if you look into the present scenario in different states as well, so the rainfall pattern has shifted. Rainfall total scenario has got totally get changed, and if even temperature also that is also drastically been changing with respect to the environmental scenario. And since the some of the key notes of climate change impact, out of this one is this global climate change. It will continue through the century and beyond, and next few decades mainly depends primarily on the amount of heat trapping gases emitted globally and how sensitive the Earth's climate is to those emissions. Earlier, during pre-independence. Actually, if you look into the CO2 emission, and now IPCC report, IPCC report, so there now totally is a huge change. So that is another alarming so far the climate change is concerned. Then temperature is continuously it is rising. Keeping in this, the human-induced warming is superimposed. And then temperature with precipitation is another important parameter. As you mentioned, it is a pattern. If you look the some of the cases, drought in the southwest and heat waves and everywhere and are projected to become more intense, and cold waves less intense everywhere with high intensity precipitation for a few hours. So some cases we have seen it, the drought as well as the floods events are is coming, and intensity to some extent it is being totally got change. So that is another, because earlier the intensity when we are designing the drainage, as for example the drainage pattern, so in different cities, towns, so that was the value, it was very small amount of value that has been considered now, so that value is changes to is a higher value. So keeping in the space constant, so that part is another issue. That's why the somewhere some cases in some towns and some cities, the flood is another big issue with respect to the climate change impact. So then if you look into the interlinking between the climate change and the hydrological cycle, because hydrological cycle, some of the parameters, if you look into this, so these are the main indicators, the 10 indicators. You can see that one is the humidity, air temperature near surface, then temperature over oceans, then sea surface temperature, then sea level, so then ocean heat content, then sea ice, then temperature over land, snow cover, glaciers. So these are the 10 indicators which lead to a global temperature, as well as which lead to a increased high rate of evaporation. And ultimately, it is increasing the hydrological cycle, and it also creates more cloud and more precipitation forming as rain rather than as snow due to increased temperature. And not only this, it also changes the pattern as well as the intensity of rainfall. And as already been mentioned, and that thus results to flooding from the excess rain, because shortage of storage due to shortage of storage, because high town planning development. So that's why the shortage storage is a crisis for us. Then obviously another issue is this frequency of drought in other region also prone to arid condition. So one by one I will highlight. If you look into the overall data, it is collected from source NASA. So they have given in the trend of spatial distribution of temperature worldwide. If you see from 1927 to present scenario, it is 2018, already been published, in 2023 that has not been incorporated here. But if you see the from 1927 to 2018, see the world map, see the condition of the temperature cycle, because temperature is a, once it is a green, it is with respect to the red, is a temperature is less. But see earlier in 1927, so if you see the world map, where Indian map also there, and see the how the temperature variation, so it is being highly decade wise it is changing. So from 1927 to 2018, so really is another alarming for us. Next, if you see the some of the events I am showing you, that also been collected from NASA. So river condition, if you look into the river, not only in all other states almost, so that river is highly, some of the events I am showing here is one river, Ganga near Patna before rainfall. If you see the condition of the before rainfall, that is the course of the river, And once the river Ganga near Patna, the high intensity of short-term rainfall, see the condition of the river is this. So that is another, because the course somehow is changing, and then total water carrying capacity is drastically been reduced, because so many silt has been deposited in the river, resulting it is a flooding. So that's why and some of the cases also, if you look into the throughout the water availability, and it is drastically it has been reduced. So that is another is concern here. So then another river, United States, river Illinois. So that is also before see the condition of the river, not only in Indian context, same as other country as well. So definitely see the river stress in before flooding, and upper one is the before flooding. So condition of the river, and after flood, once the high amount of rainfall is coming, and ultimately it is flowing into the river, and from river it is going down. So definitely the huge amount of flood has been occurred. So that also has been collected from NASA. And now the another scenario, glacier melting. So even if you see that also data collected from NASA Ireland glacier in 2016. So it is the recent data, and if you same position, same places. So in 2000, the Iceland glacier is, see, this is the same point, and if you look, there is the arrow mark, and red arrow mark. See the condition. So really is a one kind of evidence of glacier melting, how the glacier is being melted. So another is a important, is a very good example. If you see in Chile Lake in 2010, this is the picture. If you upper portion, if you go there, I mean, if you see here is the upper portion, the lake condition of the lake. So then within the 10 years, 2019, the same lake has been totally gone down. See how the lake has been totally has been silted up, and ultimately the carrying capacity has lost. So this is as a drying of lakes and water bodies. So this kind of situation is happening in every state. So this is another things is presented, and one of the recent incidents happened, and that is in Sagar Island in, West Bengal, in Kolkata, in West Bengal mainly. So because see one of the picture I'm seeing how the sea level transgression is happening is the local sea level. This picture has been taken in 2015. Actually, earlier it was that there was a tube well. So how the river, the sea level is shifting, the moving of sea towards human settlement. So this is a really is a, and this is one of the picture, and another picture is how they see that if you look into the second right hand side, the second picture. So see the tower is in the, earlier it was in the bank side, now it's totally submerged condition, the tower. So now, bottom, if you see the bottom portion, so that is one of the picture taken from Sagar Island. And recent picture I have been also taken because one of our scholars is doing the research work, and also I have been awarded one project from DST Government of India. So this is the case. This is situation is happening in Sagar Island. See the total is the transgression age is happening. So the building all the habitations has drastically been destroyed. So then some of the major cause of climate change in India. So as we know, it is if you look into the five thrust area, one is the industrial pollution. So that is also most of the cases industrial pollution is also is a major concern for us. And if you look into this issue, not only water, hydropower, then power, then thermal power, then you can say air pollution. So all are under on the same umbrella. So industrial pollution is another issue for us. So industrial pollution, that is also is concern authorities, the state-wise pollution board. So, and they are also looking, there's another thrust causing to or leading to climate change, it's industrial pollution. Then urbanization, rapid urbanization, if you look into the West Bengal population scenario per capita is a population density is really is another challenging issue because of due to rapid urbanization, water availability scarcity situation is happening because per capita water availability that has been considered as per the norms is 135 LPCD to 150 LPCD. It varies from city to city, town to town. So definitely that it is limited because the entire available resource is getting reduced day by day at a higher magnitude, at a higher rate. Since high amount of urbanization is happening, is definitely the water shortage is another issue, and deforestation is another problem because that is also is another alarming for climate change in India. So that is and another is the vehicular pollution because that also we have seen it a high amount of vehicular pollution is being generated in every towns, every cities, and that is also is another alarming. And last but not least, so the reduction of water bodies is at a higher rate. Reduction of water bodies, that is also because most of the cases we found so water bodies, wetlands, and other kind of natural sources is, that has been lost due to huge amount of due to development, due to infrastructure development, due to high rise of building and so on. So that is resulting the problem is a climate change issues in India. So then human activities have already raised the global temperature by 1 degree centigrade compared to pre-industrial level. So definitely the global warming is now likely to reach 1.5 degree between 2030 and 2052 if it is continues to rise at the current rate. The special report as IPCC report, a special report on global warming of 1.5 degree centigrade has warned. So that is another huge threat we can say. Country under severe heat warming. If you see the surface temperature left hand side, there is a one that graph, you can see how the temperature is been increased with respect to the year wise. Actually, in the x-axis it is a year 65, 70 like this, and 2015, and vertical is the y-axis is the average temperature. So how if you see the trend line, so trend line is the increasing trend line. It's the last 50 years the rate of data recorded. So definitely is another threat you can say. And lower portion we have collected from NASA is a land surface temperature, how the land surface temperature has been increased at a higher rate. So from here you can see dozens of people are reported to have died in a heat wave because due to heat wave across India that has seen temperature reaching more than 50 degrees Celsius. So this is really is an alarming threat. So in 2019 1st June, so one temperature has been recorded. Turu, it is located is in West Rajasthan, is 50.3 degrees Celsius. And if you see the downscaling down map, there is one map that is in vertical axis is the depth, and x-axis is the age, 1000 CRBP. So in that cases, if you see the two identification has been done. One is the present level, another is the time and the depth that Neolithic settlements in Gulf of Cambay. So it is recorded. So how the sea level variation during last 14,500 years with BP along with the west coast of India, and timing recently discovered Neolithic settlement in Gulf of Cambay. So this is really is another alarming situation. Some of the evidence in Indian context. So one very recently that also in Delhi. So how the urbanization is happening, and particularly how we are torturing the environment, particularly that is one of the example. So in the top portion, it is in Delhi. In 2000, there was a huge amount of forest cover, canopy cover. So now the same, if you look into the arrow mark in the down portion image, so totally it has been settled down, settlement has been happened. So and ultimately these things is happening due to rapid urbanization. So in last 2000 to 2018, how it has been changed at a higher rate. So this is one of the evidence of human torture towards innocent environment. So greater urbanization is main threat towards climate change, creating more heat island. Obviously, if forest is not there, so canopy cover is not there, ultimately the heat island would be more to changing, the creating the more heat island. Then some of the recent destructiveness of climate change that we know, and Kerala flood suddenly happened in 2018, causes from high intensity of rainfall, because these things is happening as you have mentioned. See, the drainage pattern is limited, other infrastructure is limited. So definitely, once due to rapid urbanization, industrialization, so that end product will be discharged. And since the area is limited, so there is no space to move, and ultimately it goes towards the down portion. So and the resulting the water is locked, and somehow is a water logging is happening, and resulting the flood is because due to high intensity of rainfall, that event to arrest that water or to store that water, there is a shortage of space. So the resulting is a problem, is a that also another threat. And in another Kashmir flood in 2014, that also high intensity of rainfall, because that intensity is once it is happening, so due to shortage of space, and there is a no storage, so definitely is another threatening. In 2019 also tropical cyclone, we call it the Fani in Odisha, and that is also a huge loss. And 2019 another cloud burst in Sikkim also, in that is also huge uh, incidents happened. So ultimately that these are the destructiveness of climate change. So in Maharashtra drought in 2018, as we know, day by day water table, it is a high amount of, it is depleting, because our extraction rate is increasing. And as per the authority, state-wise central board, there is a one board, we call it the Central Groundwater Board. And state-wise is a different boards, they are looking. So actually they are have some of the policy, but people are not following. And also the problem is this, particularly if you look into the small building, standalone building, so definitely there is no such hard and fast rule to maintain that law or that policy. For this is another challenging for controlling the particularly for extraction of groundwater. So that is ultimately the water table day by day is depleting due to high amount of extraction is happening. And because another issue is this, natural recharging day by day is decreasing, because natural recharging, even all towns also, the entire land use pattern got changed. And obviously earlier the area which has been chosen for natural recharging, and that area has been developed, and ultimately it is converted to lining, and there is no recharging. So in effect is the our environment problem. So that is another issue. And if you see the right hand the down portion, that picture, how the water table is lowering, in particularly in Punjab as well as the Haryana. So then water levels in India, the major reservoirs have fallen to 21% of the average of the last decade. 54% of the country's groundwater is declining faster than it is being replenished. and there is a basically is a crippling dependence on monsoon rains to replenish most of the India's key water sources, underground aquifer, lakes, reservoir, rivers, and reservoirs. So, really is another alarming. So, for the groundwater is concerned, because earlier we have mentioned the surface water, and almost all surface water is been deteriorating the quality wise, because quality is another issue. Most of the cases we have seen, it's the quality of the river water, is a high amount of pesticides is coming. So due to due to that agricultural surface runoff through that agriculture, because agricultural we are pesticides we are used. So definitely, ultimately during high storms, that pesticides it is coming with the surface water, and it is ultimately it is discharged into the water bodies. So that water body is another alarming, and another high amount of organic pollution also being getting discharged. Some of the cases we have seen it, so that STP, domestic waste, or you can say the industrial waste, that after treatment also, that also not being coming the limit which is been prescribed by the authority. So ultimately we are discharging the due to that lack of monitoring surveillance. That is an important issue for us. And with respect to the groundwater, so groundwater is another issue, because the storage, natural storage is has been decreased drastically, and even some cases somewhere we are making some of the artificial recharging, but that is also limited, and huge amount of water extracting without any control device. So resulting the water table is being depleted at a higher rate. So another issue is this groundwater is, so for the water quality is concerned, so high amount of iron is being getting, then arsenic, fluoride, and manganese. So quality issue is another issue. So for the groundwater, then saline, some cases we are getting high amount of TDS. So once we are getting these things, so definitely treatment, a separate treatment is needed to get the good quality of water. So in that cases, additional cost is are involved. So ultimately, another threat you can say, so surface as well as the ground. So Indian water resources layout. So basically, if you see in Indian context, so 54%, if you, this is the Indian map, you can say stress water, how which state, which states are being facing problem, particularly in water resource available is concerned. So 54% of India faces a high to extremely high water stress. So stress, as we know, it is defined as the, if the water per capita per year water availability is 700 meter cube per year. So definitely we call is the water stress condition as per the scale given by the Falkenberg indicator. So it is based on this, 54% of India faces high to extremely high water stress condition. So if you see the map, so is a really is another red color means dark, deep red color means high, then a little bit brown, that is extremely high, and that is some of the cases. If you see the eastern, that western part, and northern part also is another, even eastern southern part also is another issue, if you see. So really is another threat, if you can say. And some of the pictures, if you see how the people are getting water, due to the high amount of water scarcity, with this small dig of water, and this is people are getting. This is only for drinking as well as cooking, not for other purpose. And look into the right picture, see the condition of the water body. We are throwing a lot of plastics in the water body. This is another alarming threat, you can say. Microplastics we are getting in the water. Even we are placing some of the filters in the water treatment systems for removal of bacteria as well as other kinds of contaminants. But once the microplastic is present in the water, so that kind of filter, it is not being permitted, or it is not being capable for arresting that type of things. So that's why separate filtration systems are needed to arrest the microplastics. So this is another challenge, this is another threat, you can say. So if you look into this, the present the condition of the water resource potential or annual water availability of the country in terms of natural runoff in rivers is about 1869 billion cubic meter per year. This is the water available in terms of natural runoff. Out of this 1869 billion cubic meter per year, it is usable water of the country has been estimated 1123 billion cubic meter per year. And out of this 1123 year, some part are surface water, some part are groundwater, and surface water, if you see, the 690 billion cubic meter per year, and groundwater is 433 billion cubic meter per year. So these 433 billion cubic meter, if you see, then out of this, the 35 billion cubic meter for natural discharge, and then if you deduct it from 433 minus 35, roughly it is coming 398. So 398 is our entire groundwater water availability is concerned. So 398 billion cubic meter per year. Now the overall scenario, overall contribution, if you see with respect to the rainfall to the country annual groundwater resource is the 68%, and the share of the other resource such as canal, seepage, return flow from irrigation, recharge from tank, ponds, and water conservation structure taken rest 32%. So then 68% is the groundwater, and rest this mentioned this particularly that seepage, irrigation, then ponds, tanks is 32%. So these things, this is actually due to the increasing population in the country. The national per capita annual availability of water has reduced, because earlier it was in the 2001 1816 cubic meter per capita per year. So and now it has come down to in 2011 1544. So already in 2011 it was in 15%. Now we have reached in 2025. It has been already been reached less than 1200 cubic meter per capita per year. So definitely is another threat. You can say water famine conditions to some extent. Some states already been faced this kind of situation, this kind of problems, like Bengaluru, then Chennai, then other states are having problems, and people are buying water with a high cost. Some cases, some states are also not facing this kind of problems. Still, they are getting free of cost of water. But ultimately, the time will come. Definitely, we have to buy not only for drinking and cooking water, but also other kinds of water as well. So this is another threat, you can say. So for the water, due to because due to water availability decrease at a higher rate, so ultimately it's another threat for us. If you see the condition of the water resource in India, because most of the major rivers, if you look, Kaveri and Krishna, Narmada, and some of the west flowing river of south, these are the major rivers I'm talking about. Not some other rivers are also there, but Godavari, then Mahananda, and some Ganga, and Tapi, Indus, Mahi, then rivers of Puch, then Sabarmati. So if you see red color, green color, dark green, red, green, dark green. So definitely color-wise, it is percentage is given. See, so how the Gujarat or what's heat actually, because there are already water shortage. Because one is some of the river basins, the green color means the river basin are in surplus condition, and red color or brown color is the river basins are in deficit basin. We can say the deficit basin. The source has been, this data has been collected from Central Water Commission, Government of India. So really is another some of the basin, because these things is also one of the issue I should highlight here is interlinking, river interlinking. That is another problem is happening in Indian context, because when we are making the interlinking projects, so that also the state to state is there are some policy decisions problems. So ultimately we are not being success some cases somewhere. Because once we are interlinking, for us, it would be a good, but due to internal policy issues, we are not being success at a higher rate. So because otherwise interlinking is a one kind of a good solution, but definitely ultimately we should also aware, and we should also look into this, and which also is a part of the entire game, and we also think at a we should think at a higher magnitude, because ultimately the next generation is another threat for us, because they will not get the water even drinking as well as cooking. So overall the scenario is really is a problem. I am now overall consideration. If you look into the West Bengal scenario, West Bengal, because that is also why I am showing West Bengal, because earlier slide I have seen you was overall the resource in India, and I am particularly I am moving to West Bengal scenario. In West Bengal scenario, because our cases in West Bengal, a lot of river basins are available, but most of the cases we have seen it, almost all rivers to some extent has been fully silted up, and throughout the year water is not available at a higher magnitude. So definitely that is another threat, and another issue if you look into the groundwater issue in West Bengal, not only in West Bengal, other state as well, so many qualities problems. So like fluoride, arsenic, salinity. In West Bengal, we people are facing fluoride. Almost more than 43 blocks have been affected by fluoride, and 104 blocks have been affected by arsenic. So then salinity is also more than 50 blocks. Then that data has been collected from Public Health Engineering Department. So then definitely, actually, if you look into this, according to Union Ministry, they have given one chart. 11 lakh villagers in India does not have access to clean drinking water. So this is a, I should repeat this one, 411 lakh villagers in India does not have access to clean drinking water. And out of these 411 lakhs, 78 lakhs are from West Bengal. So definitely people depend on the small rivulets, which are also remains dry during summer. I mentioned due to encroachment, due to uncontrolled, unauthorized sediment is extracted. Obviously, the course, river course is changing, and some of the rivers is totally got silted up. So this really is another problem. And in West Bengal, some of the districts is having a major, huge problem like Bakura, Purulia, Bardhaman, and West Mednapur receives a scare rainfall and have high water crisis. And in water requirement, as we know, major water requirement is our irrigation, then domestic, then then hydropower, then some thermal power, then some of the cases forestry, ecology, and environment, and industry as well. If you see in West Bengal requirement of water in 2025, it was agriculture. It is 10.98 is a million hectometer. So 10.98 is our the sector which is the agriculture sector. Then domestic sector is the 0.38 million hectometer. Then industry is 0.59 million hectometer. Then thermal, earlier it was 2000, now almost thermal is being not used. So that's why thermal there is no projection. Then inland navigation is 3.63 million hectometer. Then forestry sector as well 0.01. Then ecology, environment, and others, 1 million hectometers. So that overall, if you look the 16.6 million hectometer is our the requirement of water resource in West Bengal. So that is one. Then the groundwater scenario of West Bengal. So groundwater scenario in West Bengal, I have been already been highlighted. So this because as the groundwater is available, so out of this, some of the one is called the annual replenishable groundwater resource. Another is called the net annual groundwater availability. Then annual draft. Then stage of development. So then critical blocks. Then semi-critical blocks. In West Bengal, almost the stage of development is 42%, because see how the stage of development it is being increased 42%. Then out of this semi, almost all blocks are 37 blocks are semi-critical and one block is the critical. And this the net annual groundwater availability is this 20 out of 30.36 to 27.46 billion cubic meter is our this level. So depth-wise water level, if you see in West Bengal, some cases somewhere it is really we are getting to 20 to 40 feet. It has been dropped down. So really is another issue uh, here in West Bengal. And this is one of the major conditions in river in West Bengal is the Ojoi River. In some states also same problem, same kind of things is happening. How the river is drying up the surface water body. If you see in Ojoi, in this earlier top picture, it is taken in 2006. And this 2019, how the river decreased, the course particularly decreasing surface flow due to greater extraction of water from, because some cases some river high amount of water is being extracted for agriculture purpose, and that's why this kind of rivers like Ojoi also is happening, is implied with a low precipitation and higher temperature condition, resulting the surface flow is decreased at a higher rate. And this is one of the case in construction of dam and thermal power plant in Moirakhi River in 1999. Before dam construction, the Moirakhi, one of the big river. So Moirakhi River catchment in 1999. And see, there is a one indication in one mark point is given before dam construction. And after dam, the one thermal power plant is a Bokreshwar thermal power plant is a big thermal power plant. Is basically the Moirakhi River catchment in 2019. After dam construction, because see, definitely these things can happen because it ultimately leading to hindrance to river flow regime and increase the river water and air pollution from thermal power plant. So that also is another threat, you can say. If you not control, if you not monitor, so that is another problem, because ultimately once we are intervention is happening, any kind of structure by any kind of structure resulting is a problem, but that problem we can solve it if you look into the continuous monitoring and also maintaining the all laws, rules and regulations. That things we are not maintaining, so to some extent at the end is a problem we people are facing. Then how the Moirakhi River is drying up due to climate change impact and increased utilization of river water. See, this is in the top portion, the image is in 2006, and right portion is the down portion image, same place, same area. So image 2018, see the condition of the Moirakhi River. Almost Moirakhi River is drying up due to this climate change impact and also utilization of river water. So the increased amount of utilization. So ultimately the one things it is showing in or it is observed in Moirakhi River. So high amount of human encroachment around the river basin, and another is a rapid urbanization that leads to the formation of heat island, and obviously the rainfall in this basins area also decreasing in recent days. So This is one of the conditions. Then another river, this is also important river in drying, Shilavati River. In Shilavati River, the image has been taken in 2003, and the same area. If you look into the in the upper portion, the river width. This is the in the round portion. That was the river width, and after 2003, and the same area when we took the image in 2017, so how the river course width has been changed at a higher rate. So definitely the river, that Shilavati river regime is drying up, so that's another threat, you can say. Then the reduction the water bodies. So see the water bodies. In lake portion, the picture we am seeing, one is the lake water, another is the vegetation land. So that picture has been taken from aerial image in 2003, and then same area the we have taken 2007. So that vegetation land in 2003, it was the 10 hectare, and when we have reached in 2017, it is a 7 hectare. Now we have already in 2025. See how you can imagine how much it can happen. So, and upper is the water body. How the water body get changed, and how the carrying capacity is being changed at a higher rate. See the water body area is, it was in with respect to this, it was in big in 2003, and in 2017 the water body, the area has been changed, depth has been reduced at a higher rate. So reduction of water body and destruction of vegetation cover will lead to high surface runoff and poor groundwater recharging, because that lake or pond, whatever you call, it's definitely it will helps to recharge, which is called the natural recharge. It will helps uh, for a longer time and for a long time, and obviously that part has been changed at a higher rate. So this is another example. Another thing is this, how the forest cover, and also the how the increase in bare soil condition, because that also the soil is not been fertile, and if soil is not been fertile, definitely that crop, if you look into the monocrop, then multi crops, definitely it will be a problem for agriculture farmer. So that is an issue, big issue, because that soil moisture is being reduced at a higher rate, and also availability of surface soil to recharge underground aquifer, is another. This basin is the Shilavati basin. So see the image from 2003 to 2017. So this is totally changed. Forest covered to is totally land pattern, land use pattern has got changed. So ultimately it's a problem. Now another issue in West Midnapur, that is also conversion of forested land into agricultural land. So that increase the pressure on groundwater, because when you convert to forest land to agricultural land, due to food security, food issues, problems solved. But problem is this: once you convert this forest land into agricultural land, ultimately that leads to the increase the pressure on groundwater through over extraction. That is also these things happening in that area. How human encroachment and increase in built up area may decrease the groundwater, because once you develop the human encroachment, making a high rise of building, definitely it will reduce the natural recharging, and ultimately it will hamper the ecological flow in open channel. So the same things, this is the one of the pictures taken from ATAL block, West Midnapur. And this is one of the basin mentioned. I have drying surface water due to climate change and anthropogenic activities, because that also high amount of anthropogenic activities also increased, and the abstraction of groundwater leading to lowering of groundwater depth of contamination. Even if you look into the um, uh, post monsoon, and then different basin, Kangshaboti, then Shilaboti. So if you can see the level of the basin wise, how the groundwater level has been depleting, or depth has been changed, and also some cases it is being contaminated. So far the water quality is concerned. Similarly, this is another basin, is the Moiraki River basin. So in Moiraki River basin, so in that area is problem is this fluoride affected zone. So that is once we are deteriorating the water level, or groundwater level, definitely quality issue is a big issue. And now in every state is facing problems for the water quality is cancer. So the water quality like fluoride, iron, manganese, then arsenic, and so on. So definitely, and other than these pesticides. So problem, the lowering of groundwater depth can be visualized from the map. Maximum depth in 2000, it was 8.7 meter below ground level, and in 2017 is further decreased to 22-meter below ground level. How? See, totally is really is a big issue, a big problem. Now, some of the treatment technology used to rejuvenate, because the surface and groundwater I have mentioned due to climate change, this problem issue I have been highlighted. Then some of the quality issue already been mentioned. Then how to treatment that, instead of this, once the area has been affected by arsenic, once the area has been affected by iron, and once the area has been affected by fluoride, so definitely other kinds of treatment system should be used. So one of the good example I am showing here. So in West Bengal, because most of the blocks have been affected by arsenic, fluoride, manganese, salinity, and others problems. So definitely, so we are trying to introduce, or we are trying to highlights some of the cases, instead of this that groundwater use, we can use the pond water, because pond is the, because one kind of a pond, it will help in not only recharging but also to store the water, and also that water we can treat at our own treatment technology with a low cost method. So, and ultimately, and that water, it can be used for drinking, cooking purposes, particularly the area those who are affected by them, affected for this kind of things, and also water scarcity problem. So this is, in that cases, one of the project that has been actually awarded from government of India as well as the European Commission. So, along with Jadavpur University, other the 7 team members also they are with this work. Actually, other country, Germany, then Ireland, and other country as well, Denmark. So, in that project, our main intention to make it a water treatment systems where the water scarcity is happening, and number one, number two, the problem is this, once the area has been affected, so for the water quality is concerned, so we have to make it a such kind of a treatment where people can use that fresh drinking water as well as cooking water. So in that cases, we have developed some of the treatment technology, particularly for removing the that quality issues, because in that cases this project basically we have considered in pond water, where pond water is having a less amount of suspended solids, and some of the bacteria it is coming, and some of the, because the area that has been actually covered with some of the netting systems, so that's why there was no such kind of pesticide it is coming into the water body, because once it is pesticides is coming, there is a separate treatment technology which is very costly. So in that cases, no pesticide is coming, only our main intention to remove the suspended solids as well as the bacterial load. In that cases, one low cost filtration system is available. Particularly we people can use in rural area, peri-urban area, even some area where water scarcity. So in that cases, we have used the horizontal roughing filter. HRF is a one kind of a filter media it is needed, which is only gravel is the only media, or stone chips you can say as a filter media where we can remove suspended solids. And then followed by slow sand filter, because that filtration system is needed to remove the bacterial load. So this is a very low cost treatment technology, and ultimately after disinfection that water people are getting, and they are consuming that water. So this is one of the scheme which is called the surface water schemes. Another schemes is the, since the area has been contaminated with arsenic, so there is no questions to use groundwater. So in that cases, we have developed some of the treatment technology for removal of arsenic. Once the groundwater is present with arsenic or contaminated with arsenic, in that cases, we have developed some of the filtration unit, that oxidation, then co-precipitation, then adsorption, and other treatment technologies also available. But obviously, we should keep in our mind so far the cost is concerned. So in that cases, this kind of treatment systems we have used by using the chemicals, and ultimately that arsenic has been removed from that groundwater, and resulting the water what they are getting, so that is arsenic free water, and that water also people are using in that water scarcity area. And another part was the wastewater. So entire project has been laid down from our Indian context, and our technologies followed by their technologies, finally they compare with the study. It was basically so their technology and how it is works, and our technology how it is work. And definitely their technology is good. And as an outcome I can say, but our technology is also good because our technology is a low cost technology, and our technology is a viable technology. Our technology is a sustainable technology, because that is also important issue for us to make it a sustainable structure. So overall, this is the project planning actually, how project has been completed by different activities. So overall, one important issue, particularly under this umbrella, one is the need assessment, some kind of workshop, awareness program. Then, because people also should know the continuous interaction with the villagers, some technologies, available technologies, and then finally the reject management is also important issue. So I am not going in detail these projects. This is the some of the projects issue. So step by step how we have developed. So this is one of the great example we can say in West Bengal. So then this is one kind of a structure, because at the mouth of the pond we have designed one seal trap, because silt is also carrying with that water once the rainfall intensity is high, and that silt once it is being coming and entering into the pond, ultimately that pond carrying capacity will be reduced. So that's why seal should have been trapped by using this kind of a seal trap construction. So that's why at the mouth of the pond, so we have installed, or we have constructed one seal trap design. So like this overall, this is the one kind of a, if you see the down left portion, this is one of the treatment technology given by Ireland. So their technology, this is one kind of a media they are using, and that media is also it is to some extent it is very difficult to get for our daily use, but our media is locally available. And obviously that also should that's why I mentioned that it all should be sustainable. This is a very important point for us. So I am not going in details. So this is the our projects. Then I am this is one of the water supply you can see is how it is being project has been successfully if you look into the water supply, 250 to 300 numbers of household utilizing the groundwater schemes for drinking water. Earlier really is another issues, because most of the groundwater has been contaminated by arsenic. So really, so many problems with respect to the health as well as other issues. So in that cases, social problem also has been happening. So that also it is being overcome. So by using that kind of treatment. So 250 to 300 number of household utilizing groundwater schemes for drinking water, and by using that pond water, which is called the surface water schemes, 150 to 200 numbers of household utilizing surface water schemes. So and also we are supplying through this network by networking systems using some of the stand post. So 8 number of stand post has been installed, and people are getting the water from their individual houses, and 1.32 kilometer surface water pipeline we have installed in surface water schemes, and 1 kilometer in groundwater for supplying the groundwater scheme. So roughly 2.5 kilometer pipeline has been installed, laid down in that area, and almost every household people are getting fresh and drinking as well as the cooking water. So this is another successful project to minimize the water issues. Then the groundwater treatment capacity. This is that was the actually treatment capacity. That was 15 KLD. We have, and their treatment technology it was 60 KLD. It was their treatment technology. It was the advanced treatment technology. They have used some of the filter media, so their rate of filtration is so high. So that's why the capacity is also high. So instead of 50 now, they have 60 KLD unit system have been installed. So, and pre-project status, if you look into this arsenic issues problem, iron issues problem, because iron also another issue where arsenic is present, high amount of iron is present in that groundwater. So that also been overcome, other than hardness, TDS, and turbidity. So that is the overall outcome. We have seen it. Iron problem, arsenic problems, we have been solved it with respect to the quality issue. Then, so this is the one of the slide I am showing here. They are Indian technology as well as European technology. Almost, if you look into this quality issue, so their quality, our quality, almost same. But if you look into the sustainable technology, always we should prefer the Indian technology. So that was our main challenging in that project. And this groundwater quality performance, because this is also some of the treatment actually stand post, the quality wise also pre-treatment, then a stand post, and the same kind of treatment quality is coming. So benefit of this project, which basically benefits is the local villagers are getting arsenic-free drinking water, which will reduce the health problem, and then creation of perennial drinking water source for sustainable water supply throughout the world. This is another issue which has been solved, and then in that cases, some of the online monitoring systems we have installed there, and cost-effective treatment from Indian point of view, surface water schemes, groundwater schemes to maintain the good quality. And there are some of the media they have used graphene coated, some of them with nanomaterial oxidant, some of the glass activated glass. So they are European systems they have installed, and that also we have, because we have also knowledge from them in that cases. So we have a project benefit, you can say. And another is this wastewater minimization is also because that water that also been reduced, and conversion of zero discharge also been installed, because almost all cases, all projects now the government of India has been mentioned it should be ZLD concept, zero liquid discharge from industry as well as other purpose. Once water is extracting or withdrawing or collecting, so ultimately that water, when they are making any kind of products and ultimately they are generating the waste, water, and that water after treatment when they are discharging, by maintaining the guideline given by the authority. So now it is not allowed as per the norms laid down. So that is called the ZLD. So zero liquid discharge, that water you have to use in your own premises. So that's why zero liquid discharge is another important issue for us, and that also is another big. And some of the cases, the wastewater generation, because some grey water, black water in that area we are generating, and grey water we have installed some of the treatment technology, and ultimately after treating that grey water, that water people are using for agriculture, that also to some extent for betterment of the environment, and also rate of groundwater extraction, to reduce the rate of groundwater extraction. So if we use that kind of water for small crop, or for small type of farmer, even it is very useful. So that is also another benefit. In that cases we have developed some of the unit, and ultimately so people are getting 20 liter per capita per day for drinking and cooking. Around 2000 population has been catered by installing or by developing this kind of unit. This is the overall benefits in a brief manner. And now actually another issue we are, because so rainwater is another important issue for maintaining the climate change problem, because once we have to reduce the extraction rate, definitely rainwater harvesting is the only solution. So for this, state-wise, the authority, central authority is the Central Pollution Control Board. State-wise authority, they are looking all this issue. So the state-wise, different states has given different guidelines. In West Bengal, so for the rainwater harvesting, to some extent, it is not the mandatory. But other states, if you see them, Tamil Nadu and other states, so to some extent, so they have given the mandatory rainwater you have to harvest, and that water you have to use for bathing purpose. You have to use for clean purpose, utensil cleaning, and other purpose other than drinking and cooking. But earlier it was we people are using we are giving the knowledge to the uh, people who are really facing the problems basically. So drinking is to some extent it is good for rainwater harvesting, because quality wise it is not to some extent it is harmful. By only we have to invest some of the filtration systems. But now government of India have categorically mentioned rainwater could be harvested, but that is only for other purpose, not for drinking purpose. So definitely, but because other purpose is also is a huge amount. So in that cases, in West Bengal scenario, I am highlighting others with compared to the other state. With West Bengal, in West Bengal Pollution Control Board, they have given one guideline. If your roof area is more than 20,000 square meter or greater, then the harvesting and recharging is mandatory for residential and commercial, and not for industry recharge. Industry people only can harvest the water, but there will be no recharging. So in that cases, when you applying their guideline or their rule, definitely the small building, standalone building or small type of building where roof area is less than the mentioned area, so definitely it is not their mandatory options. So once it is not the mandatory, that then obviously there are no questions. Some of the cases we have seen it. People are not aware of this, and also not be using rainwater where we should harvest, and that water we can use for flushing water, and we can use for other purpose, because instead of good quality of water. So that is another issue. That is another task. It should be mandatory because otherwise, rainwater, if we not harvest for individual houses, and individual houses also people are wasting a lot of water. And that also because in West Bengal also we are not using any kind of a water meter systems. So for individual I am talking about, not for commercial, not for industry. Individual residential we are not paying a single paisa as a water tax. So definitely we are giving the electricity cost, but we are not paying a single water tax. When ultimately a lot of water we are being wasting, as per the government laid down, because individual per capita, as I mentioned, 135 to 150 liters per capita per day. Once we are using, if you stay at your house by five people, definitely multiplying with five, so some of the value it is coming. If you if you see at one day results at your own house, almost it is almost close to double. So ultimately this some of the cases we have seen it, so a huge amount of water is being wasted. So that is also another alarming. So that's why water meters also it should be common for all, so that we can see it and check it how much water we are using, and how much water, because once we are using the high amount, definitely with respect to the total amount laid down by the authority, so definitely you have to give the extra money as like electricity, because electricity and energy is consuming and per unit cost is coming, and ultimately once we are using multiple AC, so definitely the cost is also is coming high. So like this, water is also other states also facing a huge amount of problem, like Bengaluru, Chennai, Ahmedabad. So almost all cities, big cities have problems. So really, it is a so rainwater harvesting is another good solution problems. And also we can continuous monitoring by installing some of the piezometer level to see the water table how it is declining, in which area, as well as the quality issues also. So in that cases, this is one of the adaptation strategy. And some of the measures to conserve water, I have water resource user can reduce the negative effect of water shortage through a number of strategy. These are one of the issue which is revising water storage and release program for reservoir, adopting crops. Obviously, we are changing the cropping pattern and cropping practice that are robust over a wider spectrum and of water availability, expanding and adjusting crop insurance program, adjusting water prices to encourage conservation, the expansion of water supplies infrastructure, and supporting water transfer opportunities. Damage from drought-induced wildfires can be minimized by using long-range soil moisture forecast to pre-proposition fires suppression resources. And in the long term, by changing land use regulations, also as mentioned, to restrict development in areas facing increased fire risks. This is one of the measures we should take. Another is the improvement in climate projection and long-term weather forecasts, such as forecasts based on El Nino, southern oscillation phenomena. That also is highly needed, because that is also important issue for us. And rainwater harvesting is needed at a priority level. Last but not least, so mitigation may also be achieved by increasing the capacity of carbon sink. This is also important, an example through reforestation. So overall, this is the measures to conserve water. So with this, thank you once again, and thank you to entire organizer, to entire team member, and all the participants who have patient and listen my lecture. Thank you.
Thank you, sir. Any participants? You are requested. If you have any question, you please ask, sir. I am requesting all the participants if you can ask sir any question. I think during the presentation, one of the participant has raised his hand. Who is he?
Because during the presentation, I was not seeing the individual participants. That's why it's a problem. So now, individual participants, if any problem, they can.
Okay, sir. Thank you, sir, for your informative lecture. We have seen the effect of climate change through your presentation. Viewing all the slides, we can tell that the condition is really alarming. We
Yes,
the people, we the people are deteriorating our environment day by day.
yes,
If proper attention is not given, our future generation has to face serious problem.
yes, ma'am. Yes, yes, yes,
It is seen that different measures are taken in different places of West Bengal for arsenic reduction and other measures also. Uh, Rainwater harvesting is also a very important measure for conservation of water. Really, sir, we have impressed with your nice presentation. Thank you, sir. Thank
Thank you.
you.
Thank
Thank
you
you.
all. Thank you all, and thank you all participants, and thank you, madam.
Okay, sir. Thank you.
Should I leave, ma'am?
Okay, sir. You can.